Hi, today I want to make an EMP or electromagnetic pulse device, and that's why I bought one of these super high voltage power generator modules. Let's give it a try and see how it works. Wow! Swear to God, if one of these arcs touches me, I'll delete this channel. Let's start with simple stuff. Here I have a 5-watt EMP device. If you have photosensitive epilepsy or PSE, please look away now until I say done. Okay, done. Any light is electromagnetic waves, and I was pulsing it, which would cause visual interference with the brain of sensitive people, causing seizure. I hope you looked away if you were sensitive. But the EMP you guys are thinking about is at much lower frequency than the visible light, and it interferes with electronics and sometimes damages them. Electromagnetic waves are present everywhere. Let me do a demo. I designed a circuit. The waves go through a diode and get rectified into a DC voltage that is held by the input capacitance of a MOSFET transistor, and that voltage turns it on. When it's on, it switches a relay coil to ground. The capacitor is there to make sure if the MOSFET switch chatters on and off, the coil holds its voltage for some time. And when the relay switches on, it can turn on a light from AC. Okay, I put the circuit together and now you can clearly hear the relay clicking when I charge and discharge the input capacitance of the MOSFET by touching the positive and negative lines through my body. And now the relay can turn on a light too. I accidentally connected the capacitor to the output of the relay. I noticed the main reason most our circuits don't work is because of such simple misconnections that no matter how long and hard you look at them, you don't see them. Seems I don't need the capacitor anyway. And for the love of God, why would I have to work with 120 volt AC when I can do the same thing with a stupid LED? Here we are. When I touch the input, the LED doesn't turn on unless I bring my hand close to some extension cord. See? This is an example of electromagnetic interference. In this case, it's only electric, not magnetic. Now you might be curious why my body transfers some noise. Well, congratulations, you're curious. So head on to Curiosity Stream to quench your curiosity, because they are sponsoring this video. I started watching their library of documentaries, and man, the quality, the amount of work that goes into those videos, and the content. They have some of the best knowledge and science documentaries. In fact, over 2,400 of them. You must see them for yourselves. So use my link curiositystream.com/electroboom and promo code electroboom at checkout to get a full month of free access to all of them, after which it's just $3 a month. Hurry up before they realize they're selling it for cheap. In any case, the noise that's coming from my body that triggers the circuit is coupled over my body by capacitive coupling. In fact, just sitting at home, your body picks up the power line voltage you can detect on a scope. It can't really deliver power though. With my tiny circuit, if I rub my foot on the carpet, I generate enough static to turn it on. Okay, I'll make an EMP device, but before that, let me tell you how it actually affects the circuits. It's in two ways, electric, magnetic, or both. After further investigation, I realized that I've been sweating like a pig. It was quite hot and I had to close the doors and windows to avoid noise. Maybe I should get an air conditioner. See, when two conductors fall in love, I mean when they come too close without touching, a capacitance is formed between them. So if the voltage of one rises compared to the other one, charges flow into one that in return repel the same charges from the other one. So one conductor can affect the other. And that's how my hand as a conductor was picking up voltage from the extension cord. The cord is not powering anything, but a tiny AC energy is transferred through my body, and my body voltage rises high enough to trigger the circuit. This is electric interference. The other way is magnetic. See, when you have a length of wire running close to another wire and AC current is running through one of them, magnetic fields are created around both of them that in return generates current in the other wire. Like here, I shorted the input of my circuit with a coil to ground. So now, touching the input, the circuit doesn't turn on anymore. But if I use my disposable camera flash and charge the flash capacitor to 300 volts and short the capacitor with a loop of wire around the coil, see, the circuit triggers. I think I killed my MOSFET with a high voltage spike. Always protect the gate of your transistor against high voltage. And of course, these two wires being so close to each other, a capacitance is also formed between them. And so an AC voltage in one is coupled to the other one, and we would have both magnetic and electric interference. Now, higher the frequency, the worse is the interference, because the impedance of a capacitor is smaller at higher frequencies, resulting in higher AC current to run through. And also the change of magnetic flux is faster, resulting in a stronger electromotive force, both resulting in a stronger interference. When frequency becomes high enough, the electric and magnetic fields will radiate like light much further as electromagnetic waves and can affect the devices further away. In such case, the interference can create different voltages and currents across the circuit. So like when you expect a positive pulse, the noise can create a negative pulse that can be interpreted wrong, and the whole system will glitch and crash. Here's an example. I'm measuring a square wave from my function generator. Now if I run this stupid loud thingy, you see the amount of noise on the signal. But the wavelength of the interfering electromagnetic wave must be comparable to the length of your system, because if your circuit is too small compared to the wavelength, then it rides on a relatively flat portion of the wavelength and is not affected. But if the circuit is too large or the frequency is high, then you'll have positive interference on one side and negative on the other side, and this creates strong noises over the system. So it's harder to interfere with smaller circuits, and higher frequencies interfere with those. It is like when you're driving in a wavy road and the waves are spread apart, nothing happens. But when the bumps get closer to each other, then the front of the car falls when the back hits the bump, and you keep shaking and the car is under a lot of stress. You might want to chill, mate, it's already quite hot. Now what is P in EMP? Who cares about a pulse? Why don't we just do it continuously, so not only we beat it down, we keep it down? Because in most cases a device malfunctions as long as there is interference, and as soon as it's removed, it usually comes back to life. Like my cell phone touch screen works fine until I turn on my Tesla coil, and then it starts malfunctioning and doesn't work anymore until
chances are you don't give
the hell is this?
the credit it deserves.
When I
Mushy muscle in your mouth.
turn off the Tesla coil, it starts working normally. So a continuous interference can be pretty damaging. I can imagine it's something military could use, like using a dish antenna sending high power focused interference towards an airplane or a boat, like until all their systems crash. There are two good reasons to create a pulse rather than a continuous wave like a 1 GHz frequency. First is that it takes massive amounts of energy to create high energy electromagnetic waves to interfere. Military could pull it off, but in most cases the amount of available energy is limited. So rather than cat slapping your opponent with continuous small power, you store power over a period of time and then release all of it in one strong punch. You can repeat this cycle and send a train of pulses with concentrated power in every pulse. For example, my AAA battery can output around 1 amp continuously. But if instead I charge my supercapacitor, then I can discharge it in one shot and release hundreds of... Ouch! Alright, I touched the ground with one hand and the capacitor with the other. Anyway, when you short the capacitor, you can release hundreds of amps in one shot, and that creates a huge electromagnetic pulse. The second reason is that every circuit is different and is sensitive to a different frequency. So sending one single frequency or 10 might not be enough to interfere with every circuit out there. But with a pulse, these ideally sharp edges in theory contain almost all the frequencies. Look at this sine wave tone. It generates only one spike in a certain frequency in frequency domain. But if I change it to a square wave, it generates infinite frequency spikes. So a sharp pulse is better. Maybe it's a good time to mention that beside military use or controlled lab experiments, there is no real use for an EMP device between regular people, beside damaging other people's properties, like the USB killer I talked about before, which is illegal. The information I'm providing here is still essential to design a solid product that's not affected by the environmental noise. There are tons of radiations we are making by our electronics, and we need to make sure what we design works. So this thing that creates repetitive high power pulses is a great source of interference, same as the Tesla coil. All you need to do is to make an antenna to radiate EMP, something like this loop of wire. So here we are. If I bring the loop over my meter and run it, it messes with the meter and it shows random numbers. But fortunately, it recovers as soon as I turn it off. The f is this? It's damaged already? Ah! This is the second meter I destroyed. But fortunately, thanks to my Patreon support, I can afford to cover my failures. So to thank them, I'll buy them 5 more of those scope meter thingies. So this is how in general an EMP device is made. I see some people increase the number of turns in the loop to increase the magnetic fields coming out of it. But that increases the inductance and so the impedance of the loop, and that blocks the high-speed current through the wire and makes it weaker. And sometimes people add a capacitor to the mix like this, which is fine. It creates a very high voltage here and tunes the frequency very accurately. In fact, this is one of the ways they drive the primary of a Tesla coil at resonance frequency. In fact, if you don't have access to the expensive lab equipment but know the weakness of your circuit, this is a very good way to create that exact frequency and target your circuit and improve it. Now that we know how to create interfering electromagnetic noise, as a designer, how can you improve your circuit against noise? See, any circuit can emit electromagnetic noise by radiation or conduction through the wire, or can be affected through radiation or conduction. Let's start with reducing emissions. If you have high frequency noise running through a line into a circuit, always make sure that the return line closing the circuit runs right beside the first line as a single wire or a copper plate. This way, the magnetic fields created by the first line are cancelled by the equal fields from the second line. They radiate much less and don't affect the surrounding circuits. Avoid running your signal lines in a loop. They radiate noise and absorb noise better that way. The ideal connection is a straight line. Run your pulses with slow edges rather than fast edges to avoid emitting high frequency harmonics. If possible, avoid sharp edges in your wires or PCB traces for high frequency signals. Those corners are and always place proper filtering on your lines going in and out of the system. It helps with both emissions and immunity. And to increase your circuit immunity to noise, don't place your weak lines close to the noisy lines. Place a ground plate between them to absorb the noise. Run your important signals strong, meaning that the transmitter must have a small output impedance while avoiding sharp signal edges. Place filtering capacitors on your weaker lines to filter high frequency noise. Well, without filtering your signal. And in general, keep your wires short. Oh, and shield everything with ground. If you can, that is. These are just a few tips in the endless black art of radiated and conducted emissions and immunity. If you're curious for more, then head on to CuriosityStream. Well, I mean, they don't have anything on electromagnetic noise yet, but they are a top source of knowledge, beautifully presented. You might be curious about the secrets of quantum physics, or want to learn about the ancient Earth, or how we hacked the moon by Apollo missions, or more. From science, nature, history, technology, society, and lifestyle. They are the world's first streaming service with great non-fiction knowledge and science documentaries, including exclusive originals made by some of the world's best filmmakers, featuring some of the world's greatest scientists, available on all sorts of platforms. So definitely go to curiositystream.com/electroboom and get unlimited access to this treasure box, and use promo code electroboom during the sign up, and your membership will be free for the first 31 days. And trust me, you will enjoy them. And thanks for watching to the end.